Hello, everyone. This is Abdullah Sauri, and this is the second video of the series of Cadence tutorials. And in this video, I'll show you DC analysis. So we built this inverter. We added two sources and two MOSFETs, as well as we labeled the input, output, the ground, and the VDD, and we edited the properties of the DC sources. So I forgot to tell you in the first video, but every time you do a new thing, add a new thing to the circuit, don't forget to check and save before you proceed any further. So check and save every time you add or modify the circuit itself. And this check and save will show you if you have any warnings or errors. In any case, if you have an error, it will show up in this window. So it will tell you if there is any errors here, and depending on that error, you'll have to modify the circuit and avoid that error, or actually solve that error later on. But for now, we did a schematic check, and it has no errors. All right. So the next step here, after we do all this, is to launch something so we could start off our analysis or configure our analysis, and then from there on run the simulation and then plot the outputs. So for now, we'll have to open something called ADE Explorer. This will pop up, and then you'll have to choose the create new view in case you don't have any views. So later on, if we have this view and we want to open it up and launch the simulation again, just to see the results all over again, you'll have to click on open existing view. But for now, we don't have any views, so we'll have to create one. So select this and then select OK. And select IMV, and Maestro is the view. So these are the defaults. I didn't do anything. And then I select, and as a default, it will show up as a new tab. So click on OK. And this will create the Maestro view. In the Maestro view is where you will add the analysis, add the outputs, and whatever you want to plot is going to show up here. So let's do that. It'll take a couple of minutes. Okay, so now we're ready to add analysis. So the first step here is to add analysis. So let's add analysis. After I click that, this window will pop up. And so you have trend and DC. These are the ones we're interested in most of the time. So first of all, we'll do DC analysis. So I'll select this, and I'll check save DC operating point. And then what we will vary here is the input to the gate terminals, or the input to the inverter itself. So let's select the component parameter, and then select component. This will take us to the schematic window where we will select the component itself. In our case, it's the DC source that is connected to the input of the inverter. So let's wait. All right, so it showed up here. So we'll select this, click once, and a window will pop up like this one. And so what will vary here is the DC voltage. So select that, and then select OK, and then go back to Maestro view. So if you open up this again, you'll see that the component name has changed, or V0 will show up. So this is the DC source that we had in the schematic, and it's called V0. And the parameter name, just as we chose, it's called DC. So we're done with here. Now we'll go to the sweep range, which is the range that we'll sweep. In our case, the maximum voltage of the 45 nanometer GPDK is 1 volt. And the minimum we could go is 0. So let's type in 0. And for the stop, let's type in 1. You don't have to type in V for volt, but yeah, let's just keep it this way. And for automatic, for the sweep type, we could keep it as automatic, but I'd go for linear. And step size, I'd go with 10 millivolts. And so what this means, a step size of 10 millivolts, is that from 0 to 1, you will step the voltage or change the voltage 10 millivolts at a time. So this will go as 0 to 10 millivolts to 20 millivolts to 30, etc., etc. So I'll keep it this way, and I will select. Oh, we could choose the number of steps as well. So let's say I could choose 10 steps. So from 0 to 1 volt, you could just step the voltage up 10 times until it reaches 1 volt. But yeah, I chose 10 millivolt of step size, and I will click on OK to add the analysis. So now we added the analysis here. It will show up as this. So yeah, here you have 0 to 1, 10 millivolt step size. It's linear. And yeah, basically that. And it will show you which parameter or which component we are sweeping here. And that's about it. Now we'll have to select the variables or the nodes that we want to plot on the output. So in our case, so let's go to outputs to be plotted, and then select on design. This will take us back to the schematic window, and there we will choose input and output. And after we choose those, you can see it is highlighted in color. So now we don't want to choose anything else, and we'll keep it that way. So in this case, you'll just have to escape this highlighting mode by pressing on the escape button. So press on the escape button. Now you're out of the highlighting mode. Now go into Maestro, back into Maestro, and you'll see the input and the output signal is inserted here. So for now, I'd usually go for, so if you want to plot this, it automatically gives you a checked mark on the plot setting. And I'd want to go for save as well, just to keep these data inside the Maestro view. So later on, if you want to come back and then you want to view these data again, all you have to do is just click on the plot, run the simulation here. In order to run the simulation, we click on the play button on the right, green one. So I click on it. Wait a couple seconds here. So now that it's running, this window will pop up. This is basically the log window, and it will show you that the simulation is running. So once that is done, it will tell you that Spectra completes with 0 errors, 1 warning. It might be any kind of warning. I'm not sure what it is right now. So this graph will pop up. So let's just click on undock here. So there's this square with an arrow, a diagonal arrow. Click on that. So you'll get the graph window show up like this. And you can see here the input and the output because we plotted that. So what happens here is we swept the input from 0 to 1 volt, as you can see here. On the x-axis, it's the input voltage. And on the output, you can see that the output of the inverter just goes from 1 to 0 as the input goes from 0 to 1. So that's the basic functionality of the inverter. One point here I'd like to point out is this crossing of both traces is where your threshold logic threshold voltage is. So let's just say I want to see what that value is. So what we could do is zoom in. If you want to zoom in, it's right click, hold, and then drag the square wherever you want to zoom in, and then release the button, and you will actually zoom into that place you want. So I want to see what this point is. So the smaller or the narrower the square is, you will zoom even closer to that point. So I'm making a smaller square here, and you can see here I'm getting closer to the point. I mean, this is one way of looking up the value. So the more I close in on the point, the more decimals you'll get, or the more digits you'll get after the decimal. And you can see here it's in between 495.4196 and 495.4198 millivolts. So yeah, that's basically it. This is one way. The other way, so let's zoom fit this graph again and press on F to fit the screen once again and go back to the original view. So now what I want to do is I want to see what this value is. So one way to do it is press on M for marker. So pressing on M will give you a marker here. And so you could get closer to that point and it will give you a more accurate value, or maybe less accurate. So as soon as you get into that point, you'll have that value. Let's make sure we are at the right point. We may not be, but yeah, that's what it is. Yeah, it's giving me a right point. So what this is, it shows you the x-axis and the y-axis. So the x-axis and the y-axis are not completely equal, and you can see the point is a bit offset from the crossing of both traces. So what we could do here is bring it to this point as much close as possible. So this is one way you could see. You can see here that both values are equal. So this tells you what the threshold or the logic threshold voltage is of the inverter, or the switching voltage, maybe. So yeah, this is what graphing is in Cadence. Now, this is the end of the video. The next video will talk about transient analysis. So we did DC analysis. The next one is transient analysis.